Welcome to day 16 of the series on Common Lisp. So for the last few days, we've been looking at grep and we will continue to look at grep today. So while doing this, so the thing I need to show you is the actual core architecture of grep, and now I'm working on it. We'll get there. But before we do that, in today's video, I want to talk about something else, something known as anaphoric macros. So let me show you the problem first before explaining why or what this does. So if you go in the last video, I was talking about adding our command line options. And if you see the core code here, this was the thing that we were doing. I was talking about this yesterday. We get the option that we want. And if it's true, right? If it's not set, if the option is not set, then nil is returned. If it is true, then we do something, right? For instance, in this case, we are setting a different variable. So that's an easy case, right? But if you take this example, I showed you in the command line when I ran the number of jobs, like I wanted to give dash J4 or dash J8. So first I need to check up the options to see if it's set, if it's not nil, and then I have to actually use that in some way, right? So I'm going to use that variable 4, the value 4 or 8. I'm setting a different variable here. So if you see here, there is this small repetition of me having to do this getf of options and again do that again, which is not ideal, right? So this is a waste of code and also of execution. Another way to organize this would have been to put a let body and then map this once and then check it and then use it, right? But can we do something better? And yes, we can. So the let's just take a detour to what anaphora is. It's, I mean, not going to grammar here, but it's a very simple thing. Maybe the easiest way to think about it is pronouns, right? So in this case, Susan dropped the plate, it shattered loudly. So it's very clear in English or in other natural languages, we use pronouns like this. It here is referring to the plate, right? So this is a very ordinary pattern in natural languages. Now, in Lisp and maybe in some other languages, we have the same concept in the form of anaphoric macros. I don't know if this is a very, as far as I know, I've only seen this in the context of Lisp. Maybe few other programming languages which have this powerful features can get you here, but most languages don't have this, right? And the idea is very simple. So the idea is you have this pronoun it that you can use in certain contexts to mean what just came before. So the simple example that they are referring to here is that the built-in loop macro has it, the it anaphoric macro. So let's just quickly try it. It doesn't make a lot of sense in this case, but we'll get there. So if I open the console and I'm going to do something like loop for I from 0 below 10, right? And if I just do like print, right? So if I just wanted to print, I could always do or collect, right? Let's take collect and I, and this works, right? So now if here instead of I variable, if I do it doesn't work because where does it come from, right? We have not defined it, so that doesn't really work. Instead, if you have a when condition, so let's say if you have something like when I, so that means we're just checking if I is true. It's a very simple case. This time you see it actually works. So basically it refers to whatever expression you gave to when. So let me take a better example here. Let's say if we do something like this, right? So I plus 10 is obviously going to always be true in this case because these are just numbers. But it here will refer to the result of this expression. So I don't have to do this again, right? Makes sense. So it has some kind of limited use in the context of loop, the inbuilt loop. But there are other variants, other common Lisp constructs where it makes more sense. And the simplest example is anaphoric if, right? I think that's the most common example. And this example also makes it very clear. So this is how you can define the macro. Basically, it's very obvious if you understand what's going on. We just going to expand and create this variable it manually inside and then expose that, right? Once you create it, you can just use it. Now, don't worry about how to create this macro. Just see how we are actually using this macro, right? So in this case, anaphoric if plus 2,7. If it's true, which it's going to be, then in this expression, when this executed, this it is actually equal to the result of this expression, right? Now, You can define your macros like this manually, but you don't have to. This is common Lisp. There's a library out there, and the library in this case is just called Anaphora. So simply ql quick load Anaphora, and you're good to go. Now there is this code of this library, but maybe let's just go to the documentation and see what we get. Right? See, you see here, we get two families of anaphoric macros. Basically, the first set starting with A, so all of these variants, A and, A let, A prog1, A if, and so on. And a second category based on simple macro let. So this is all S starting with S, right? So this, the simplest thing is this one, the one that I've used in my code. So let's see that. So if you go here, in this version, I've just put this manually. You can see there's this repetition. I don't want that. So if you go back to my log and check the very next comment, you will see that I have replaced this function with this. So here it's now anaphoric if of my expression, and then in the body I can just use it, right? That's it. It's as simple as that. So if you see my code here, if it's clearer, it's the same code. This is what we just saw. We are basically importing if from the anaphora library and just using it like this. Same thing here, another variable I'm just setting here. I'm getting the option chunk size. If it's nil, nothing will happen. This thing will not execute. If it is not nil, if the chunk size, the user has specified some chunk size like 3000 or 4000, I'm going to set this parameter with that value 8. So this is basically a nice smooth way of writing code. Now there are a lot of more variants, and if you want to understand what each of this is doing, maybe good to check the code once, the documentation. For example, let's take this alet, which is like a very simple version. Basically it says it binds the form, the first argument, to it and violet and the scope of body. So what does that mean? That means I can do something like alet plus 2 comma 3. This is the form that will execute, and then let's say I want to use this in a few ways, like, so I want to format, let's say I just want to print it. So what I'm saying is right there you go, right? So it's just going to use now this may not make immediate sense. You might say that, oh, I'll just use a normal let form, and you could, right? But just think of the ease of programming or writing your constructs. You don't need unnecessary things when you have constructs like this. Of course, you could have multiple lines here. So instance, say you're going to log this value, you're going to send it over message, you're going to print it, etc., do order computation. The it variable is available to you in the body of this let, new let, right? And now to think about this slet variant. So basically the question is, why do we, if you understand what a let is doing, what is this slet doing, right? And I will explain that with a simple example. Let's basically create a structure, right? I mean, I could use a structure, or I can use a list. Maybe let's just do structure. So let's say this is my test structure, right? And I have a single slot key. Okay, now I'm going to create a variable of this type. So make test, right? I'm going to set the key value to nil. Now maybe I don't have to set it explicitly, but so I get a warning because I didn't def var a, but you see it exists, right? So I have the variable a, and it's a structure of type test with key set to nil. So now if I do if, right, let's do the simple version. So if a do something, right? Let's say what I want to do is, in this case, if it's nil, we'll do nothing. Sorry, if it's not nil, so if it's true, we'll do nothing. So we'll just say format true, right? And I'll just say print the value of a. If not, what I want to do is I want to set the value. Sorry, what I want to do is I want to get. Okay, maybe this makes more sense. So I want to get the key of the variable a. So a is the structure, and the key of a, if that is nil, I don't do anything. If it's not nil, I need to again set the value. So if I do set key, test key of a to 10, right? So if I run this now, what will happen? I'll have 10. So if I print out a, the key is set to 10, correct? But if you see this code, there is this repetition of test key of A twice. And I cannot use the A if version because this gets evaluated, right? Whereas if you want to use it as part of setf, you need to use symbol macro because you want that expression to remain in this place. So we can actually try this. So what I'll do is I will reset A. So A is back to nil. And let me just use the anaphoric version. So if I use anaphoric version here, and I can actually print it, like I want to print the field, and here if I try to do this, right, this is what I'm trying to say. If I try to say this, what will happen is it is not working because this line doesn't make any sense. But if I use the symbolic version of the same anaphoric macro, and now if you see here, the value is set to 10, because in this case what has happened is it is able to use this. If you see the documentation back to the if version, we see here this is if existence, the first argument unevaluated to it via symbol. Okay. So here this it is actually this whole thing replaced as a macro, as a symbol macro. So it's the whole text repeating again. So this is macros in its true power form. So now this time it's going to print. So it's going to the first path, and if you see here, this time it printed the value that we wanted, right? The key. So because it's already set, it's going to go through this path, and this time it actually evaluates it because that's how we're using it. So there is, I mean, this library gives you certain kinds of anaphoric macros. There is very interesting ones here, but there is, you can look at this nice resource on anaphoric macros in Common Lisp. It's tracking with the same thing. They show you the code for different variants, and there are some interesting things also I wanted to show you here. For example, this a while anaphoric macro. Now, the anaphora library that I showed you here does not have a while, but you can create your own macro. Obviously, it's just these 4 lines, right? You can literally just copy paste this and you have the anaphoric while macro in your hand. And the idea there is you can, it's a very, very intuitive thing. If you think about it, you have some function that you're calling and you want to use the result in the body of that thing in a loop, right? So this is very obvious. I think we have seen, this is a very common pattern where I've seen you have to write some extra code to capture the value and then check it and then use it in every other language. But here, with the power of macros, you can basically make this much smoother. So I'll share a link to this document. It has some interesting insights about the different structures that are possible, anaphoric lambda, anaphoric blocks. None of these are there in the anaphora library, by the way. But if it's useful for you, you can easily define it and use it. Bear in mind though, the definition, some of the definition of these anaphoric macros, for example, the a and don't match the one in this library. So what I mean is, when you check the code here and the documentation here, you understand, for instance, with a and in this version, it binds the first argument to it and for the rest of the arguments, right? It's only the first argument. So if I go back here, so what this means is a and let's say we do something like this, and the second argument says plus phi it, right? So what will happen? The first expression will execute, the result is phi, and the second expression will execute, and the result of the first one is set to it. So then your final result is going to be 10, right? Now, what if I do this? So what do you expect if I do this? What do you expect, right? So we get the same answer 10 because what is happening is the first expression executes and then that phi is it here, and then this it is the same phi here, right? We didn't do any setting here. We just add this expression. But if you see the definition in this PDF, this I and, or at least the documentation, the description here says that it is successfully set to the value of the next expression. So it keeps, so in this particular example, first you take the owner of X and then that becomes it here, and then you take the address of that it, and then the next expression here, that it is actually the address now. So then you can get the town out of the address and so on. And even if one of them fails, the whole thing will fail. So this is a very nice setup. I think this is definitely useful in many scenarios with nested data structures and structs and so on. In some cases, anaphoric macros are considered dangerous. I think mainly because you don't actually explicitly have the definition it anywhere. So even this documentation says anaphora claims to be from hell. Extensive use of anaphoric macros is not good style. Now, this PDF also talks about this concern about whether it's right or wrong. And I think the conclusion here is that it's okay if you are explicitly using a new macro or like AF, right? So if you do this where you are actually redefining if itself, then it's a bit more dangerous. Instead, we are using like new variants, new symbols here, like AF. So it's very clear that something different is happening. So in that case, maybe that's okay, right? It's not that dangerous. Still, I leave it to you. I think they are great. I don't think you need it. Like if you go back to my code, the entire time that I developed the all of grep, I didn't really need it until the very end. But it's a good pattern to keep in mind, and maybe it's useful here and there. Just simple ways to make writing and reading code more smoother. That's the whole power of macros.